Welcome to Lesson Overview 1.08, Similarity and the Pythagorean Theorem. In this video, we are going to prove the angle bisector theorem and prove the Pythagorean theorem using triangle similarity. We're also going to solve problems using the angle bisector theorem and the Pythagorean theorem. So proving the Pythagorean theorem, it is believed that Pythagoras, a Greek mathematician and philosopher, proved the Pythagorean theorem, which says that if you square a and add it to b squared, you will get the hypotenuse c squared. This happened about 2,500 years ago. Now, many proofs of the Pythagorean theorem exist, but here we are going to incorporate the principles of geometry to prove the theorem. The properties of triangle similarity and the angle-angle similarity postulate will serve as key concepts in the proof. The angle-angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So before you explore the proof of the Pythagorean theorem, let's consider the relationship of the ensuing triangles when an altitude is constructed to the hypotenuse of a right triangle. Notice here you're given triangle ABC. It's a right triangle. Therefore, you know that the measure of angle A is 90 degrees. Construct an altitude AD based on the definition of an altitude. You know that the measure of angle ABD is 90 degrees. And now the measure of ADC is also 90 degrees. Based on the angle-angle similarity postulate, triangle ABC is similar to triangle DBA because they both contain a right angle and angle B. Perhaps the most famous and useful mathematical property is the Pythagorean theorem. This tool is used extensively throughout mathematics to solve problems. The Pythagorean theorem is a mathematical rule that relates the lengths of the sides to a right triangle. The theorem can be used to solve for unknown side lengths when two side lengths of a right triangle are given. For all right triangles, the sum of the squares of the lengths of the legs A and B is equal to the square of the length of the hypotenuse C. I know that that's a little bit tricky, so let me show you a quick picture. Here's how the Pythagorean theorem works. So it says the sum of the squares of the sides of a right triangle equal the squares of the hypotenuse. You're never going to believe this, but if you count these blocks right here, you see that there's 9 of them. And then you count these blocks right here, you see that there's 16 of them. So when you add these blocks and these blocks up, you're going to get 25 because 9 plus 16 is equal to 25. So the sum of the squares of the sides of a right triangle, the sum of the squares, the adding of the squares equals the hypotenuse. Let's see how that works in math. So we're going to write the Pythagorean theorem. A squared plus B squared equals C squared. Now, we're going to substitute some known values here. Let's say that we're going to substitute 5 squared plus 12 squared. We want to see that it equals C squared, which is the hypotenuse. So, A squared plus B squared equals C squared. 5 squared plus 12 squared equals 25 plus 44. We see that 25 plus 44 equals 169. Now we need to undo this C squared. In order to do that, we find the square root of 169. The square root of 169 is 13. Therefore, this is a 5, 12, 13 triangle, which is a right triangle. What is the value of B if A equals 9 and C equals 15? Well, let's plug it in. So we know that A equals 9. We'll plug that in right here. And we know that C equals 15. We'll plug that in right here. 9 squared is 81, and 15 squared, or 15 times 15, is 225. Now you're going to go ahead and subtract 81 from both sides, which is going to give you B squared is equal to 144. To undo a square, you find the square root. So we're going to find the square root of 144, which is 12. Therefore, B is equal to 12. We can double check that, of course, by plugging in 12 for B. 9 squared is 81, 12 squared is 144, 15 squared is 225, 81 plus 144 is 225, and of course, that is equal to 225. If you have any questions about this lesson, please give me a text or shoot me an email.